Apart from doing the selection on a layer based on another layer, you can also join the information from one layer based on the spatial information of another layer. So since we have two layers with spatial information, now I can have the information of one with the other in different ways. So let's see how we can do that. So first of all, we can go to Tools in Vectorial Data, and there's an option to join attributes by location. That means that the attributes that were in the table of one layer are going to be um, become a new column in the attributes of another layer based on the location. So right here, we're going to choose the entry layer for yield with the observations of each one of the parcels, and then um, a join layer with the yield of the polygons. It will be the yield of every municipality. We choose intersection for the points that I'm interested in, and these are the fields that we need to add. So we can add all the fields or just a few of them. So currently we're interested in yield, so let's just add yield on the meantime. And the type of join, we're going to get the attributes of the first localized object. I'm going to do this because since every point can be in one municipality and there's no more than one municipality at the same time, so the first one is enough. If it was the other way around, we could take an average of all the points that are on a municipality or other statistics that can be calculated. And there's another option if I want to remove registries that weren't able to join. And this is not the case because all of them are on the municipalities, but you can keep it here and it's going to have a null value, or you can simply not take it into account. So I'm going to use a prefix here like census, and I'm going to keep everything as temporary. So I execute, and this is the result. It's going to be the same points that I had in the yield and with the same location. But now, if I open here the attribute table, I have this yield, census yield. So these are the new values you can see. These are points that are outside the municipality. But we have all of the values for yield here. And this can be very important to do comparisons. For example, if I want to see every producer and how they are related to the average of the municipality for that year. So this is the type of analysis that you can perform by doing this. This can be used to extract information from two vectorial layers. So I have a different layer with lines or polygons, let's say, and I can use this tool to join the attributes based on location. It can also be interesting to extract information of data that are raster data. Like here, we have the data of the organic carbon from the soil. So in order to extract the information from a raster based on the location data of the points or the polygons, there's a tool, or there are plugins and complements, but there's a tool in the newer QGIS versions that's in the process tab in the toolbox. And these are the advanced options, but they're more complete. So many of the things that are not here in the menus are included in this toolbox. So I'm going to open it and I'm going to search for the tool that's called sampling or muestreo to show the values of the raster. This allows us to do what we need to. The help is in English still here. This allows us to create a new vectorial layer with the same attributes that the entry layer, plus the values that were included in the raster data in the location of the point. So that's what we want to do, to know exactly what the value is of organic carbon in this raster. so that I can have all this data set with all the possible information from each one of the points. And this can be used for other types of analysis. So the entry layer, we can keep this one, this join layer that has the information of the polygons. And right here in the raster data would be this one for organic carbon. The prefix, let's use a SOC once again, soil organic carbon, and I'm going to keep it as temporary. So keeping the results as a temporary file or layer allows us to do this when you're practicing or when you're using data that's going to be used for another process. But you don't need to save it. These are the sampled points. They're below, so let's put them in the first part so that they are visible. So these are the sampled points. And if I open the attribute table, now I have the soil organic carbon based on the raster. So we are adding columns for the location. And to conclude this part, we are also going to add the layer soil information, the layer for soil information in Chiapas. So in this sample points that already have the data of the soil that comes from the raster. So once again, let's go to the vectorial tab in data management and attributes deal by location. The sampled points could be the entry layer, the soil information, the join layer, intersection, and now we're going to choose, we're going to remove this ID that's not interesting for us, and then we're going to keep everything else. I'm going to put here only the attributes of the first one, and as a prefix I'm going to use soil once again, joint layer, and now we save it. So this is going to take a few seconds, and once it finishes, we have the joint layer that holds the information of everything that was in the columns of the soil polygons. So this is the same information because many points were in the same polygon, but you also have information from all of those. The yield information of the point, the yield for the municipality, the organic content data from the raster layer, and also the data of everything, even the organic matter in these polygons. So these are some of the tools that can be used for building a database from different sources. And normally this is done in R. It's easier to automate and remember where all the menus are and everything. But this is also a possibility because it allows you to see things more visually. You can see errors more easily. So that's why I'm showing you how to do this. And there are many other things that can be done. You can look in Google and you're going to have you can have more answers on how to do different things. And now to conclude, once again, in the part of style and this join layer, first we're going to save it. Both of them are useful, but let's export and save the objects. Now we're going to choose the name called database. This holds everything. So I'm going to remove this ID. There's problems with this one. All of the columns that I'm interested in, then accept. And I am going to remove all of these that were temporary layers. And when the project is going to be saved, and you're going to close the QGIS session, it's important for all the temporary layers have been removed or saved, otherwise they're going to be lost. So my database I can copy the style. So I'm going to copy everything here, and I'm going to paste it here. So this is very easy to change. So I not only have the yield, but I can also show the yield of the census, for example. So I can compare the information with the yield of every point with the yield for the census in each point. So you can see that the values of the points are the same within every polygon of the municipalities. And that's where the information is coming from. And all the additional information is here also. So I can look for the organic carbon. And this carbon is what comes from the raster layer. So if we see here in this layer, the scale is different, but you can see that the data is the same. We can change the scale or the color palette so that it looks more similar to the ones we had before. And these are the points of the carbon values. We can also change the polygons for organic matter. So you can compare with the raster. You can see that there's a big difference now. But if we compare this with the values of this one, it must be a lot more similar. The scales aren't exactly the same, but you can see that it's very similar. So this is one of the objectives, you being able to have all the information in just one database to perform analysis, to do predictions, models, to do explorations, etc. So this would be the end of this module.